So we're going to define another new term here. So we're going to define curl. The curl of the vector field, which is mi plus nj plus pk, is curl. It is the gradient across the vector field. So it'll be the partial of p, the partial of p with respect to y, minus the partial of n with respect to z, I, plus the partial of p with respect to x, minus the partial of m with respect to z, j, plus, that should be a minus here. This should be a minus, plus the partial of n with respect to x, minus the partial of m with respect to y, k. So this is the formula for curl. Okay. And if the curl of f is 0, then f is said to be irrotational. So let's look at an example where we calculate curl. Find the curl of f of the vector field x, y, z. It's going to be 2xyi plus x squared plus z squared j plus 2yzk. And I want to know, is f irrotational? So we start by computing curl. The curl of f, it's the gradient across our vector field. Now you don't need to memorize that formula as long as you remember how to compute the cross product. So here we have I, j, and k. And the gradient is the partial with respect to x, the partial with respect to y, and the partial with respect to z. And then we're going to copy down our function, our vector field. It was 2xy, x squared plus z squared, and 2yz. So then remember how we compute these cross products is we break it down where you delete the first row and the first column. So it'll be the partial with respect to y, the partial with respect to z, x squared plus z squared, 2yz, I, minus, now delete the first row and the second column. So it's partial with respect to x, partial with respect to z of 2xy, 2yz, j, plus, and then delete now the first row and the third column. So this is the partial with respect to x, the partial with respect to y of 2xy, x squared plus z squared, k. So then, remember how we compute this, you subtract diagonal minus the other direction. So you're going to take the partial with respect to y of 2yz, which will be 2z, minus the partial with respect to z of x squared plus z squared, 2z. Now I take the partial of x with respect to 2yz, there's no x there, so that's 0, minus, going the other way, the partial with respect to z of 2xy, well there's no z there, so it's also 0. The partial with respect to x would be 2x minus, then the other way, the derivative with respect to y would be 2x. So here you're getting 0i minus 0j plus 0k. So in the end, you're getting the 0 vector. So that's what the curl is equal to. And then we would say that f, to answer the second question, f is irrotational since the curl of f is the 0 vector. So you do need to remember how to compute cross products in order to compute the curl.